In this lecture, we will be discussing a very important topic in economics, or at least in microeconomics, which is called elasticity. Now think about a store. Often you have seen stores like Macy's or JCPenney or any kind of stores like Amazon. They give discounts, which essentially means that they will reduce the price. Now obviously we'll know that according to law of demand, as you reduce the price, your quantity demanded increases. Now, one of the challenges for firms is this to find out if they reduce the price by say X percentage or say 20%, how much their quantity demanded is going to change. Because in the end of the day, if you reduce price, if your quantity demanded does not increase by substantial amount, then it doesn't make sense to give the discount. And often elasticity helps us to measure the degree of change in quantity demanded as a result of change in price. Now let's try to understand this using an example first. So we'll draw two demand curves, one elastic and another inelastic. Let's try to draw a demand curve first. So we'll be drawing, so we all know we measure quantity on the horizontal axis and price on the vertical axis. So let's draw two demand curves. One is steeper, like we'll call it D1. Another demand curve we'll draw, just go through this, we'll call it D2. And let's say we start with price here, say $5. At $5, according to these two demand curve, both are demanding say 10 units. Say this is, let's say this is quantity of ice cream. So these are 10 ice creams. Now if D1 and D2 are two demand faced by two different ice cream sellers, suppose the price decreases to say $4. Suppose both decide to decrease the price to $4. That means we are going to see a decrease in price. Now at $4, you can see here, according to demand 1, you might be demanding say increase say around 12, but according to D2 it might be 18. So what you see here, depending on how flat or steep the demand curve, so is the change in quantity demanded. So for $1 decrease in price, according to demand 1, quantity demanded goes up from 10 to 12. On the other hand, for $1 decrease in price, for demand D2, quantity demanded goes up from 10 to 18. Often in economics, this flatter demand curve often is called elastic demand curve. On the other hand, the steeper demand curve is often known as inelastic demand curve. So under elastic demand, what we know, if a price changes a little bit, it leads to a bigger change in quantity demanded compared to inelastic demand. A price change from $5 to $4 leads to only 2 units change in quantity demanded in case of inelastic demand. Now question is, how do we measure all these things? What's the measurement for elasticity? That's what we're next slide. So price elasticity of demand is nothing but the degree of responsiveness to quantity demanded to a change in price. So we are trying to measure the degree of responsiveness, how much the quantity is going to change if the price changes. And often it's measured using a formula, which is percentage change in quantity demanded divided by percentage change in price. And how do we calculate all these things? We calculate this using change in quantity demanded over change in price times initial price by initial quantity. Now if you do a little bit algebra, actually percentage change is always calculated as new minus old by old times 100. That's percentage change. So if you're trying to calculate the quantity percentage change in quantity demanded, you just use this formula. use the same formula to calculate percentage change in price. So basically, as price changes, how much is the change in quantity demanded? This will become clearer if we do an example. So this is an example. So in the fall of 2006, Pace University in New York raised its annual tuition from $24,751 to $29,454. Freshman enrollment declined from 1469 in the fall of 2005 to 1131 in the fall of 2006. So what we try to find first is the calculate the price elasticity of demand. Then we ask the question, is the demand for places in freshman class elastic or inelastic? So let's try to first calculate. So we all know our elasticity of demand is percentage change in quantity demanded over percentage change in price. So first we'll calculate. So in this example, what's the price? Price is the tuition. Tuition is the price paid by the students. And what's the quantity? From college's perspective, college is a seller of education and students are the demand. So this 1469 and 1131 is the quantity demanded or quantity demanded of Pace education. So first we'll calculate percentage change in price. So percentage change in price, which we all know new minus old over old times 100. So what is the new price? New price is 29,454. What's the old price? Old price is 24,751, and you divide it by 20 old number, old price 751 times 100, that gives you 0.19. Then we'll calculate percentage change in Q, percentage change in quantity, which is number of students who are willing to buy the Pace product, which is education. So what's the new number now? Is 1131 because less people are going to buy it because of increase in price. What's the old number? Old number is 1469, and you divide it by the old times 100. So it gives you negative 0.23. So finally we'll calculate elasticity of demand. Elasticity of demand is percentage change in Q, negative 0.23 over 0.19, which gives you negative 1.21. Now when we calculate elasticity, we always drop the negative sign. So you don't have to worry about the sign here. So don't drop the negative. So we'll just drop it. So what you are worried about is the number 1.21. So how to interpret this 1.21 number? It means that 1% change in price leads to 1.21% change in quantity demanded. Obviously, price and quantity moves in the opposite direction. So that's why here a negative number means that if price increases by 1%, quantity demanded is going to decrease by 1.21%, and vice versa. If price decreases by 1%, then quantity demanded is going to increase by 1%. So that's how you're going to interpret this elasticity of demand. Let's discuss varieties of demand curves, because it can be elastic, it can be inelastic. So let's try to understand it. So first, this demand is elastic if price elasticity of demand is greater than 1. So if it is greater than 1, which essentially means that demand is elastic. Demand is inelastic if elasticity of demand is less than 1. If the number that you calculated is less than 1, then it's inelastic, which essentially means that if price change by 1%, that means quantity demanded is going to change by less than 1%. Demand is unit elastic if it is equal to 1, that means 1% change in price leads to 1% change in quantity demanded. Demand is perfectly inelastic if elasticity of demand is 0, which is basically means the elastic demand curve is vertical. That means if price changes, it has no impact on demand. Let me show you this. So this is your price, this is your quantity, this is your inelastic demand, where if the price is say $1, still demand is same. If price increases to $2, still demand is same. The same here, say let's 10 units. So in the case demand curve is vertical, the demand then elasticity is 0. Finally, we have perfectly elastic, which is if the elasticity of demand is infinity, which means demand curve is horizontal. So this is a case of perfectly elastic demand. So perfectly elastic demand, which means that a small change in price can just wipe out all your sales completely. Again, perfectly elastic or inelastic demand are theoretical cases. So let's try to understand each of these one by one. So first we'll start with the perfectly inelastic demand, where it's 0. You can see is vertical. As price increases from 4 to 5, it remains 100. Inelastic demand is generally steeper. So at $4 they're demanding 100 units, at $5 they're demanding 90 units. So a 22% increase in price leads to an only 11% decrease in quantity demanded, which makes it inelastic because your change in quantity demanded or percentage change in quantity demanded is less than your percentage change in price. This is a case of unit elastic, where at $4 100 units are demanded, at $5 80 units. So a 22% increase in price leads to exactly 22% decrease in demand. So elasticity is equal to 1. We have elastic demand, which means as price increases from 4 to 5, it decreases from 100 to 50. That means a 22% increase in price leads to a 67% decrease in quantity demanded. That means a small change in price leads to a huge change in quantity demanded, which is elastic demand. And finally, perfectly elastic demand, where demand is a horizontal line and it's infinity, because if you change price by little bit, you really don't know what's going to happen to demand because there's no associated demand curve involved. So it is again a theoretical case which we will be using in a extreme scenarios, but typically it doesn't exist in real world. You can have a very elastic demand, but you never will have a perfectly elastic demand. Similarly, you will have a very inelastic demand, but you will never have a perfectly inelastic demand. So next, to understand what are the determinants of price elasticity of demand. One determinant is the availability of close substitutes. So goods with close substitutes are more elastic. Think about things like Kellogg's cornflakes cereals versus say store brand cereals. They are pretty similar goods. Maybe Kellogg's tastes a little better, but they are pretty similar. So if the Kellogg increases their price too much, you know that people will be moving to buy store brand cereals, which might be cheaper. So if a good has a lot of good substitutes, then the demand for that good is elastic. Necessities versus luxuries. So necessities are inelastic demand. Think about water, salt, milk. We pretty much want to buy it any price they charge. Or under the COVID-19 situation right now, I'm sure a lot of people are buying the face mask at a premium. On the other hand, luxuries, which is like super luxury things like expensive cars, expensive jewelry, typically have elastic demand because if people don't have money, they will not buy it, right? If the price increases too much, people will not buy it. It's not a necessity. Elasticity also depends on the definition of market. A narrowly defined market means more elastic demand versus a broadly defined market. Again, example, suppose you are looking at market for Coke. Yes, Coke is a specific brand. Demand is very elastic because if Coke prices increases, people will start buying Pepsi. But if you are looking at a market for soft drinks, demand is inelastic because you are looking at a broader market where it includes all the Coke, Pepsi and everything. If overall prices for the beverage market is going up, that means people really don't have a lot of choice outside the soft drinks because so many companies only sell those soft drinks. So you really don't have a lot of choices. So it also depends on how broadly you define the market. And finally, it depends on the time horizon. So demand is more elastic over longer time horizons. For example, if you have an exam tomorrow and you have to buy a calculator today, you might be willing to pay premium to buy it from a very expensive store in the local area. On the other hand, if you know your exam is in 2 weeks, you might order it in Amazon or somewhere else where it might come at much cheaper price. So time horizon also matters how elastic or inelastic your demand for goods and services will be. So these are some of the factors that affect demand for goods and services, or elasticity of demand for goods and services. Now we'll continue discussion. Next we'll be discussing elasticity of supply. The idea here is exactly the same as demand, so we'll not be spending too much time. So let me define it. Price elasticity of supply means the percentage change in quantity supplied divided by the percentage change in price. That means you are trying to measure the responsiveness of the percentage change in quantity supplied to a percentage change in price. And this is how you calculate it. So you just divide the percentage change in quantity supplied by the percentage change in price. Only thing is this, elasticity of supply is always positive. And the reason is simple. We all know, according to law of supply, as price increases, suppliers would like to sell more and vice versa. So price and quantity supplied moves in the same direction. So the elasticity of supply will always be positive. Now, how to interpret different elasticities? Exactly like what we have done in demand. Supply is unit elastic if elasticity of supply equal to 1. It is elastic if it is greater than 1. Elasticity is inelastic if it is less than 1. Perfectly inelastic, as you guessed, it has to be exactly equal to 0. Perfectly inelastic, on the other hand, which is a vertical supply curve, and perfectly elastic, which means your supply or elasticity supply is infinity, which means a horizontal supply curve. So here again, idea here is this: we'll pretty much be moving around these three things. These are extremes. Inelastic and perfectly inelastic and perfectly elastic are two extremes. So what elasticity does, it helps you to figure out if you're a buyer or seller, if there's a change in price, what would be the reaction in the quantity supplied and the quantity demanded. And it helps to make actually informed decisions in a market. And that's why often firms try to collect so much information about you to find out at what price you're willing to buy a product. And essentially what they're doing, they're trying to measure the elasticity of demand for the products that you are trying to buy or sell.